example number 3. Once again, let's try to get more comfortable with using the quadratic equation. It doesn't matter, the point out is that it doesn't matter what the A value is, what the C value is, and what the B value is. Now I want to solve for x again. But in this equation, let's say we're going to have to pay a little more attention to it. The equation itself start out not looking as a general form yet. The equation itself doesn't start out being in a general form. So I need to bring my equation back to the general form. Once again, because I can see that, well, I have my x squared term on the left-hand side, but all the other terms are on the right-hand side. I do not see a 0 here. So what I need to do is I'm going to need to subtract 6x from both sides, and also add 1 from both sides. And doing that is going to result for me a 3x squared minus 6x plus 1 equals 0. Now at this step right here, my equation is back in the general form where it makes it ready to use the quadratic formula. So now at this point, once again, one more practice for us all here. The A value, which is the leading coefficient in front of the x squared term, is 3, including sign. My B value, including sign, negative 6. And once again, please, I strongly recommend that you have to get yourself into the habit of looking at the coefficient here, including the signs. Do not skip signs. We are in the world of algebra now, so we always need signs to come along with that. My C value is a positive 1. Okay, so now back to the quadratic formula. To find x could be obtained, the value of x is obtained by minus b, and b in my case here is negative 6, so I have minus negative 6. Plus and minus 1 long square root. I have b squared, which is negative 6 all squared, minus 4 times a times c, and all that here we divide by 2 times 3. So now in my next step, once again, negative 6, that makes it minus negative 6, makes it positive 6. Plus and minus, long square root here, underneath the square root. Let's start computing these little chunks here separately. Now minus 6 all squared is a 36 positive. Minus 4 times 3 times 1 is minus 12. And all divided by 6. And so in my next step here, we have 6 plus the long square root here. It's now going to become, now 36 minus 12 underneath the square root is going to be a 24 divided by 6. And so this time 24 itself is not a perfect square. It's not a perfect square, so I cannot just simply find the square root of 24. However, what we can do here is we can simplify, we can reduce that square root 24. And I noticed that 24 contains a factor of 4. So, and once again, if you're not sure how to do reducing square root, make sure you look back, check out my other videos on for Math 1033 material, so that you can once again learn and gain your skill in reducing square roots here. But now I have 6, which is the first 6, plus and minus. Now square root of 24 is reduced into 2 square root 6. And we divide it all by 6. So my two answers would be x equals 6 plus 2 square root 6 divided by 6. My other answer is going to be x equals 6 minus 2 square root 6 divided by 6. Now in this case, the only thing extra that we can do, the only thing that we can do a little further here is just to simplify the fraction here. Now each term here has a common factor of 2, so I can cancel it out. So my first value here is going to be 3 plus square root 6 divided by 3. That's my first answer, and we cannot go any further into finding the precise value for 3 plus square root 6 over 3. The other answer here is going to be 3 minus square root 6 divided by 6. Divided by 3. So you can see that in each answer, I just cancel the common factor of 2. I cancel the common factor of 2 away. The last example for showing you how to find the quadratic formula, example number 4. which is also our last one in the quadratic formula. Okay? And we want to solve for x squared minus 2x plus 17 equals 0. So, once again, this equation, the good thing, it's already in general form. So, the x squared term, the x term, the constant term, the c term, and there's a 0 on the right hand side. So, everything is good. Now, it's all just getting ready for the quadratic formula. Now, my a value here, my leading coefficient a value is equals 1. My b term, my b coefficient, including sign, is negative 2. My c term, including sign, is positive 17. Okay? So, for the quadratic formula, I have to verbalize it one more time. Minus b, in this case, minus negative 2, plus and minus long square roots. B squared, which is negative 2 r squared, minus 4 times a times c. Okay, all that here gives me divided by 2 times 1. Okay, so continuing with this expression here, continuing to evaluate the whole formula here, what I have is now minus negative 2, that's giving me positive 2, plus and minus, and here it comes the long square root. Okay, minus 2r squared is a 4. Now negative 4 times 1 times 17, that's giving me minus 68. Okay, we divide all that here by 2. And so in my next step, the part underneath the long square root here is 4 minus 68 is going to become square root of minus 64. And then we have 2 plus minus, and you divide by 2. And so now, in this problem, once again we're encountering with the square root of a negative number. So we've learned how to handle negative number underneath the square root. Square root of a negative number is going to give you, square root of negative 64 is going to give you 8i. So once again, think about square root of 64 itself is 8. And then this, because it's square root of a negative number, we have the I attached to the 8. And now the usual 2 plus and minus right in front and divided by 2. So once again, in this problem we do end up with a complex number. Okay? But then that should not be a surprise to us because we have all learned about complex number back in those problems where we solve using the square root problem. So once again, the plus and minus here means we have 2 solutions. One of them is 2 plus 8i all over 2, and the other answer is x equals 2 minus 8i all over 2. And of course, do not forget that we need to simplify each of these expressions. Now I have a common factor of 2 for each of these fractions here. So I have 2 cancel with 2, 8 cancel with 2, so that gives me 1 plus 4i, and the other answer 1 minus 4i. And these are my 2 answers. And that is all how we can use the quadratic formula. Sometimes we end up with real solutions like the previous 3 examples. Sometimes we just end up with complex solutions just like these, where it involves the imaginary components.